The next step is to trim off the form at the top from the tower itself. So the way I'm going to do that, and it has to happen in between, well, before the deconstruct B-rep, and I'll explain why. Has to happen before the deconstruct B-rep because we're going to use that surface a little bit later on. So what we want to do is look in intersect, and we're going to use solid difference under shape, solid difference. Oh, shape, that's what it's under. So this asks for two things. It asks for the first B-rep set and the second B-rep set. And I will tell you that I very, very consistently get turned around between which one is subtracting which with this kind of thing, because it's not exactly clear. So sometimes you might plug it in at the bottom and really you need it to go in on the top, but we'll just play around with it and figure that out. So we need to reference this poly surface into our Grasshopper workspace, but there are some restrictions that I think you should be aware of. When you are referencing in a poly surface, in most cases, it's best to reference it in as a generic geometry. Right? So if you go under params geometry, you want geometry or B-rep, because B-rep is going to be a more compatible format. I think, and it might actually work, but I think if you just use surface, it might not be able to rectify it. But let's try it. So I go to set one surface. Ah, that's why. Okay. So I go to set one surface, and I'm going to pick the back surface that's actually trimming it. Oh, it won't even let me do it because it's a poly surface, I think. It's a solid. It's reading as a B-rep. So let's use B-rep. So I'm going to set one B-rep, and I'll select the box. So it likes that because the box is reading as a solid rather than a surface. And I'm going to plug that into A. And then I'm going to take the join, the B-rep join, the B output. I'm going to plug it into B. So turning these off, which one did it leave? Ah, so I have it backwards. So what it left me, let me turn that layer off too so you can really see it. What? See what I mean? It came through backwards. So it actually subtracted the tower out of the box. And what I really wanted is for the box to subtract off of the tower. So that's what I'm looking at there. Okay. So you're understanding that now. So now when I turn on my extrusions, and let me turn off the difference of my tower and increase the number of extrusions. Oh, look at that. I forgot. I need to plug this back into the surfaces. So this will have to override. I'm going to very quickly override into the boundary box here, but if I take this box instead of the loft, then it will get trimmed. And I'm going to go back to my original setup at first, but you know, this one here gets trimmed. And so if I'm going to rotate these, and let me look at it kind of from the top back a little bit like that. And if I rotate those, they're all going to be trimming based on where that box is in 3D space. Okay, so that is a drastically different tower than what you had just seen. Okay, So it sounds like some of you guys probably need a little bit of fixing up out there. So I'm going to get you set up with that before we move on. So moving forward, now that we kind of have our truncation at the top all figured out, I'm going to go back and start moving in a bit of a different direction. Let's talk very quickly about kind of the structure of high-rise towers before I move forward. But essentially, the concept of a sky lobby is pretty prevalent. And they're all interior photos. Hold on. I forget what it's called, but oh, come on. What is that building called? Anyway, so here's a kind of an interesting example. So structurally in high-rise towers, usually you have packages of floor plates that are structurally bound to some sort of, frame that gets either hung from above, or it gets mounted above the, well, I'll draw it on the board, okay? So it's easier to explain in pictures. So you'll have what's called a tube structure. Kind of in the center, you'll have like an elevator shaft. And then you'll do kind of this outrigger structure like that. And that would be like a big truss or a moment frame or something like that. And all of the floor plates are either mounted above in compression. So everything gets put on columns that lead down to that structure, or it gets hung below in tension, and then they all get mounted with, a tension member like that, hung down. So using that format, it opens up the possibility of a sky lobby. So if you're using a tension system, and you've got your tower going through or your structure tube going through the center, if you're doing tension, you can put a whole bunch of floor plates below and a whole bunch of floor plates above and have a really cool lobby up there, right? And so there are a bunch of different things. We could talk all day about what the benefits are of doing that. It gives you mechanical space, it gives you circulation space. You can, your elevators can stop there, and then you can feed another elevator up to the rest of the building. So sky lobbies are a huge thing with high-rise design nowadays, but I want you to be aware of that because I just want you to think about packaging this kind of data. So when you're designing a high-rise, it's not just going to be 150 floors that are 15 feet apart all the way up. It's going to be different. It'll vary. So the information that you're going to package needs to be broken in a couple of ways. So perhaps in this tower, you might have, excuse me, you might actually have the packages of 20 floor plates that are going to be spaced with a sky lobby of 35 feet. Okay, so let's take a look at what we would do for that. So if I've got a package of 4 floor plates, let me slide all this out because we're going to modify into this a little bit more again. So if we have a package of 20 floor plates, which is right here, actually I'll put that back, sorry. I want the same number of floor plates, and I want to move them up so that there's a gap of 20 feet before the next set of 20. So the challenging thing is that now this is the geometry I want to move. I want to move the linear array rather than the actual extruded forms, because all of this is a functioning set of data. So I'm just going to start plugging in my packages into the BREP and then feed it into boundary surface and then feed it into the extrude. So let's take a look at what that looks like. I am going to slide that out. This geometry, we are going to move it vertically. So let's go to transform, Euclidean, move. and we can plug the geometry into the move. And let's tell it how far we're going to move it. So here's where clever mathematics, simple arithmetic is really going to help. If I know I have a 35-foot gap, all I need to do is move it along the z-axis I need to move it a distance of, and let me go under math operators and do addition and multiplication.
Is that one?
Huh?
I was just wondering if there was one.
No, they're two separate ones. These are under math operators. So we are going to multiply the number of floors times the distance between the floors, and then add however many feet we want in our sky lobby. Right? Pretty simple stuff. So I take the count, which is 20, I multiply it by the distance, which is 14, plug that into the first value of addition, then I make a slider for 35, and I add that, and it gives me the numerical value of 315 feet, which, when I plug that into move, gives me the gap for my sky lobby. Does that make sense to you guys?
Can you zoom out a little?
Yes. So I'll clean it up for you a little bit here. So now I can actually move that and increase the gap in my sky lobby if I want. So if I increase it to 40 feet or 50 feet, it makes it a little bit larger, a little more obvious. All right, so here's the really cool part. We can then kind of gang these together, and the copy and paste for this is really going to be pretty awesome. So I do copy and paste again, pull it down, paste, pull it down. I don't think I'm going to need more than 3 packages of this. And the difference here is that rather than, let me slide these out a little bit. So we have all of these that are coincident with one another. And the thing we need to change is the referenced geometry. So rather than moving the original linear array of surfaces 3 times, we're going to then move the modified and moved or relocated linear array. So then that is the geometry that I replaced down to the transform. See how it moved it up one set? And then I connect the next one, and there we go. I've got 4 packages. Does that make sense to you guys? So I want to make this information easy to digest and plug in somewhere else. So I'm going to introduce to you another just really awesome management tool called Merge. And you saw that in the definition that I gave to you yesterday. Merge is an easy way to get one singular output of many of the same type of data. Okay, so all of these are packages of surfaces. And if I go into params, no. Is it param? No, it was under sets, tree, merge. Sets, tree, and merge. And next week we'll talk a little bit more about data trees. But sets tree and merge, it looks like there's only two inputs here. But once you plug in one set of data and plug in the second set of data, it adds a third set of data. So you noticed my merge in the script that I gave you yesterday was like 20 or 40 some odd lines long. So it gave me one singular output rather than plugging in something 40 times again. And so what are we going to do with this right now? Can anybody lead us along? Right, we're trying to replace our original surfaces with this new set of modified, packaged data.
And you want what?
So we have our original set of data that we modified and we cut up and we trimmed it to the surface skin, then we truncated it. And so now we just created packaged sets of floors. So what do we want to do now if we want to do the same thing that we did originally, but to all these new packages? Right. Yeah, we want to plug it into the BREP and just override that input. So I'm going to turn these off so that you can really see what's going on. Now this is what I have. So now I've got sky lobbies built into the cadence of my floor plates. Yes?
Once I make the initial one and I copy it over, it keeps on the same place. How do I get it to spread out, the different ones?
These, once you did the copy of those.
Yeah.
So originally, these packages of geometry were all plugged back into that. What you need to do is plug these in a like a gang chain, right? So you're going to daisy chain them together. Make sense? And then I plugged them back into a merge and fed it back up to the top, just to make it a little easier with one input. Okay, so this is the point I want you to get to before we start doing some skin and facade exercises. Let me move this down so you can see what's going on. Ooh, that's tough. Not enough room. You guys got enough there? Can you see that?